I hope you're having a wonderful day. In this video, I'm going to teach you how to get first-person movement in your game, including looking, walking, sprinting, jumping, and crouching. Right-click in the hierarchy, go to 3D Object, then Plane to create a ground plane. Then reset its position and scale it up. Next, create a capsule object and search for a rigid body component. This is going to tell the engine to include this object when simulating the physics. Make sure to disable rotation on the X, Y, and Z axes so the player doesn't fall over. Move the camera to the top of the capsule object, then parent the camera to the player object so that they move together. Play with the FOV until it feels right for your game. Then go into the player object in the inspector and disable the mesh renderer. Create a new script and name it movement. Next, double-click to open it in your editor. I'm using VS Code, but it doesn't matter for this tutorial. I linked a video to download VS Code in the description if you're interested. First, define yaw and pitch. These are going to store the camera's rotation angles. The sensitivity is essentially just a multiplier between our mouse input and our camera angle. Next, define rigid body and speed. RB is the rigid body we'll use for physics-based movement. Now in the start function, change the lock state of the cursor to locked to keep the mouse centered and invisible. Then we can automatically initialize RB to this component's rigid body using .getComponent. Here, we'll change the pitch by our mouse Y input multiplied by our sensitivity, then clamp this value from -90 to 90 degrees. We can do the same to our yaw, but without clamping it, because we want our player to be able to sprint around freely. Finally, we can just set the main camera's rotation to the pitch and yaw values we just calculated. Note that I'm now in the fixed update function because we want our movement speed to be independent of our FPS. Vector2 axis is going to store our WASD input multiplied by our speed. The forward vector is a little bit trickier to define, however, because it is dependent on the direction the player is looking. All we have to do is rotate the camera's right vector by -90 degrees by swapping X and Z with -Z and X. We can define a vector that's perpendicular to the ground plane by setting the Y value of the vector to 0. Which direction is the actual direction the player needs to be traveling in the game. Forward times axis.x is the forwards backwards movement, the main camera's right vector times axis.y is the left-right strafe, and our up vector times our linear velocity is what maintains our current vertical velocity. Finally, set the rigid body's linear velocity to the which direction we just created. It's okay if that was a bit much, you don't have to understand the vector math to use it in your game. That pretty much covers the basic movement. Now I'm going to get into how to add the more advanced movement mechanics to your game. So at this point, you should have perfectly functional first-person movement for your game, and it's completely fine to stop here if you want. However, many games require more advanced movement mechanics like sprinting, jumping, and crouching. If that's your game, keep watching until the end to learn how to add them. In order to jump, two conditions have to be met. 1, the player has pressed space, and 2, the player is on the ground. To check if the player is on the ground or not, we can raycast downwards from our current position at a max length of 1.1. If it hits something, the player is either on the ground or very close to it. If these conditions are satisfied, we can add an upwards force to the rigid body. Sprinting is also pretty easy. First, define two speeds, your walking speed and your sprinting speed. Then, every frame, check if the shift key is down. If it is, set the player's speed to the sprinting speed. If it isn't, set the speed to the walking speed. Crouching. A simple way to achieve crouching in your game is just to shrink the entire player on the Y-axis. Also in the update function, add a check to see if the C key is down. If it is, change the local scale's Y value to 0.5, otherwise set it back to 1. And that's it, we're done. Thank you for watching. I hope this video was helpful or at the least informative for you. If it was, please consider liking the video or subscribing to my channel for more. If you're watching this video, I'm going to go out on a limb here and say that you're new to Unity. If you feel as lost as I did when I started, ask a question in the comments and I'll do my best to respond to each and every one of them. See ya!